Hey guys, my name is Angel Varela, and this is my thought process on ALA5. And I chose to do problem B, predict the major products of the reaction below. And this is my with this starting material and these reagents. So I look at my starting material first, and I see that this is my benzene ring right here. And I determine that these are my substituents, right? From here, for my substituents, I determined that this one up here, since they're both alkyl groups, or R groups, I determined that this one is more impactful to the benzene ring due to this bond being able to be used in resonance, and then the lone pairs right here also being used for resonance. Because if this moves over here, have a positive charge right here, and then these bonds could come down, these lone pairs come down here, and I form the double bond right here with the plus sign right here. So with that out of the way, I deem this as more important. This is a stronger activator, and alkyl groups are para-ortho activators or directors. Sorry, so that means from this R group, para would be right here. So this is where the substituent will be added, and then leaving a carbocation up here. But anyways, going to step one. I forgot the name of this reaction, but I do know the mechanism. So I have a hydrogen over here. This hydrogen will be moved over here to this carbon, breaking this carbon-chlorine bond, and this chlorine will use one of its lone pairs to attack itself or attach itself to aluminum trichloride. The products are aluminum tetrachloride and this carbocation. I also know that carbocations want to be as stable as possible, so this will perform a 1,2 alkyl shift, meaning that this hydrogen shift will come down over here, moving this positive charge over there. Comparing this starting material with this starting material, the one on the left is secondary, while the one on the right is tertiary. Carbocations that are tertiary are more stable due to hyperconjugation from these carbons over here and their hydrogen bonds. So knowing that, my ending products, or my products of the activation of my electrophile, are aluminum tetrachloride and this carbocation. Coming back to my starting material over here, this carbon will use the lone pairs right here to attach itself right there, leaving a positive charge over here. The reason being is, again, this is my stronger activator, and an alkyl group is a para-ortho director. So since there's nothing on the para side right here, it will attach itself right there. Going back down here, it will leave the positive charge up here, the cation, and then the aluminum tetrachloride, comes in, uses the lone pair, takes that hydrogen away, and uses these bonds to make the ring again. So at the end of step one with the reagents, we're left with this, and we're also left with, I believe it's aluminum tetrachloride with this chlorine over here and a hydrogen up here. And the thing is that these will readily just come together and form HCl along with AlCl3 again. But I just didn't include that, but just so you know, it appears. So after that, we're left with the free radical bromination with MBS and HV. So when you're dealing with free radical addition, or sorry, not free radical bromination, there's some things that you do have to keep in mind. The molecule cannot be tetra. It can't be bonded to 4 carbons, right? So in this case, we do have a quaternary. There you go, quaternary carbon right here, right? Because we have to look at the benzylic position. Sorry, I forgot to include that. But this is only with benzylic positions, right? So the benzylic position just means that it's attached to the benzene ring, but it's a carbon attached to it. So it's not of the ring, it's just attached to it. An example of that is this one right here, this carbon right here, this carbon right here, and this carbon right here. So knowing that it can't be quaternary, it rolls out this one from the free radical bromination. We're left with these two right here, the top one and the bottom one. After writing down every single resonance that could appear from the radical being formed here or the radical being up here, I found out that the more resonance stabilized free radical would be the one formed down here. And the more stable it is, the more likely that radical will form, and the more likely that radical forms, the more likely that's your major product, right? So knowing that the free radical will form here, this is just really a simplified version. I just put the BR just attacking it over here. And I am left with this guy right here. So yeah, that was my thought process on ALA5 Problem B. Let me know if I messed up anywhere, or if you have anything different, or if you just have any criticism about it. It helps, because to me this seems right, and to others it might not, and I might have gotten it wrong, and the only way I'll learn is if you guys point it out. But other than that, that's been me, and yeah.